Alright, just a follow-up from last week. We're going to walk through a couple examples for how you might be able to make more custom graphics, custom data visualizations, starting with some of the environmental analysis that came out of Ladybug. So we'll start with, we're just going to go over a couple examples, one being the view rows and how we can redraw that because it's a relatively simple one. This is the base file for that, and I'll kind of move through that one. This one we don't need any added analysis from Ladybug. We can get away with just using one component here, which is the view rows component. So let's go over to the Ladybug tab. Of course, you'll need to have this installed. So if you need to do that in the labs, start off with that first. And we go to the environmental analysis, and we'll find the view rows component here. And we can go ahead and give it the context. And actually, I'm going to put it up over here. We also have to give it a plane from which to work. So this is going to be basically the center of our viewing. For that, we can just take because this is just a box. Our geometry is our building, and that's just a box. So all we have to do is, in this case, we'll just go to surface and grab the volume component, and that'll give us a kind of center point through the volume. You can give it any center point you want. Any point on screen will work. I'm just going to say kind of somewhere in the middle of the building. And then I just want to go to vector and put an XY plane at that point. And we can turn off the preview for both of those things. And we can plug the plane in here. And all we got to do now is just give it a radius. I've been working off a radius of 50 meters. Which seems to work pretty well for the scale of all of this. And so this is what we saw a little bit last week. So we're going to take this surface that comes out of here and redraw it in a number of ways. And I'm also going to introduce the human add-on for Grasshopper that also gives you some extra custom display options to set up some nice screenshots, or even just kind of test how your graphics might look when you do some post-processing. So let's see what's coming out here. We have the blocked curves. So this is the curves that are going to make a closed polyline that shows the angle. Anything behind this building from our angle of view will be impossible to see. So from whatever angle from here, because of that building, we won't be able to see past. So that's a kind of a blind spot. And then the view rows itself is actually what we can see, within that 50-meter radius. So let's start with the blocked angle, and I'm just going to put a component on that. So this way, bringing out the outputs separately allows me to work on them independently from one another, so I don't get confused. And I'm just going to, introduce a couple basics from Human. If you don't have this installed on a Mac, don't worry. Just follow along a little bit. This is not a mandatory part of the tutorial. I just thought I would kind of cover this because it's helpful in the conversation of custom display options. So I'm going to grab in Human, I'm going to grab the custom preview line weights component and plug in the geometry. And then it's going to ask you for a shader, so you can give it a color swatch, and that's probably starting to get used to this. We've used a lot of these, so that's over in the parameters tab. I'll make them black. And then this is a cool component because it allows you to change the on-screen thickness of the lines, so it gives you an option for setting a kind of a line weight, if you will. Unfortunately, you can't give it line weights that are in between numbers, so it has to be full numbers, no decimals. But it does give you at least a little bit of control over how fat something looks on screen. Remember that none of this is just a preview, right? So it's going to be pretty light on the computer, and you could, pretty good for sketching out ideas right here in Grasshopper without having to, take it in and set line weights and stuff. Okay, so that's just a simple one, in terms of the blind spots, setting up a line weight around the blind spots, and you can use this for any geometry that comes in that are lines or curves. I'll turn that off in just a second. For now, we'll leave it on. I'll go back over to Human, and I wanted to show you the hatching components, which are also pretty nice. So over creation over here, we can grab create hatch. And it's going to need a few things. We have to tell it which hatch pattern we want. By default, it's going to go to solid. And if that's fine, you can leave out the next step. But sometimes it's also nice to have, some idea for, or at least the ability to swap out hatches to see other options. So I'm going to go to document info, grab my hatch table, and what this is going to do is pull up all the hatches that I have available to me in my current Rhino file. And if I add any custom, they'll show up here as well. But this is the basic hatches that come out, that are just loaded up when you open up Rhino. And then to select, these are all just in a list. So to select these, I could just grab a list component, set, list item. And, because we've got 9 things in here, I can make a slider between 0 and 8 and just plug that in. And that's going to go into the N input there, which is going to tell us what our pattern name is. And sometimes it's good also to have a panel off of this, because now we could see, what it's telling us here. So let's see, maybe I'll try hatch 2 or something, see how that comes out. And the other thing, I guess, is the hatch scale, which you can also make changes to, so that's pretty nice. So I'll put just put a 1 in there for hatch scale. And it's likely that I'll make some adjustments to that. Okay, and that's good enough. We can then route this through our custom previewer. So we'll go to display, custom preview. The geometry that we're going to be customizing is going to be the hatch itself, and that's going to come out as curves. And then we can give this a color. So I'll just grab another one of these. I can just copy and paste this one here, and maybe just drop its opacity or something like that. Alrighty. Alright, and it's still orange because we haven't given anything to hatch yet. So what it's looking for in the C input here is the curves that are closed, something you can hatch. It works exactly the same way as it does in Rhino. So if you were in Rhino, you would select a polyline or any kind of region, and you would hatch it by running the command. In this case, you just have to input the curves. So we have those coming out here. And, so here we've got a result. And there's the hatch 2 with a 1 scale. It's all pretty light, pretty quick, and pretty nice. We could add a different line weight to this if we'd like, of course running it through here if we wanted to add some thickness to it. You can see that. In this case, I'll leave it with a border. And let's change the scale maybe to 0.5, see how that goes. Yeah, that's going to make it very, very tight. So it depends on what your output is, if you're going to print large or if you want something really fine with very light line weight. You can make that decision as you move. And it's kind of nice because you don't have to, in Rhino you got to rehatch. Well, actually that's not true. You could just change the object properties for the hatch. But sometimes it's nice also to be able to work right through Grasshopper to get these things set up. Okay. And then if we go over here, we could make changes to the hatch and see how that. There's a grid hatch. I like this one a lot. This is the one we used for the shadows before. Maybe make that a little larger. Yeah, you get the idea. Cool. So a little bit about human and hatching. Of course, all of this can be done in Rhino as well. So again, not mandatory for this. So I'm just going to, and one thing I wanted to mention is that these are curves. So if you do bake these into Rhino, you could post-process as you see fit as well. In the next one, I'll talk about how you're going to get stuff out of, those of you using human, if you want to use it. We'll talk about how we could bake the attributes so that it bakes exactly like what we've got here. And we'll talk about that in the next tutorial. So for now, I'm just going to go ahead and turn that stuff off. And we'll get working on what we're going to do with the actual viewing angle. And this will be a little bit more involved. So let's look at what's coming out of here by default here. So we can just turn this on. Yeah, again, we're getting this surface that comes out of here. And we're going to take that as a base geometry and populate it with some points and draw it in a couple of different ways as a gradient condition, something that, the farther away we get from the building, maybe the smaller a circle gets. And we're going to use that as a way to to visualize this in a different way. So this will tell us our viewing angle, but it doesn't say much about distance. And you might be able to suggest through a gradient, field pattern or some kind of field condition, how your view. Sure, that certain things that are further away might be harder also to see, even though they are within this viewing angle. Okay, so I'm just going to turn that off, and we'll just start because we know it's there. I don't need to see it, and I'm just going to get. So let's go to vector, and let's see. In the grid tab, there's this thing called populate geometry. So this is going to just populate any kind of shape that's closed with a random distribution of points. All right, so our geometry is the view rows itself. The number of points we want is going to be pretty high, all right, because we're working with a pretty big surface here. So I'm going to type in 5,000 and let that think for a second. It might take your computer just a minute. There we go. So we've got a random distribution of points within the boundaries of that surface. Okay, to speed things up, I'm going to turn it down to 1,000 for now, and then I'll increase this later. It's always a smart thing to do until you're ready to. When you know everything's running really smooth, then you could go ahead and make that change. Okay, and we're going to set a gradient condition here, and we need to tell it how to. We need to tell the computer what's going to set the parameters of that gradient. So what we're going to do is we're going to measure the distance between the center point that we used back over here, the center point, and all the other points. And the furthest something is away, we'll at least know, and we'll use that information to start to remove some of these, remove more of them from the outside and keep more of them on the inside as a way to get that gradient pattern to come out. All right, so we're going to go to vector and distance. The first point is going to be this center point here, and the what we're measuring is all these other points. So that's going to give us a whole range of distances here. Okay. The other thing I'm going to begin to do is I'm going to throw in the random component here. So we're going to go to sets, sequence, and random, and I'll get back to this in a bit. But I'm going to plug in that 1,000 in there too, because we're going to need those numbers to match up. All right. Okay, and in this case, I find it easier to sort all of these distances and then resort the points based on closest to furthest away. So we'll go ahead and go to list, sort list, and what we're sorting is actually the distances themselves, and that's going to go ahead and do that from small to large, and then the geometry that we're going to sort along with it are all the points. So it's going to reorder these points based on where they are relative to that center point. Okay. And then we're going to take all those distances and remap them between 0 and 1, and we'll talk about that and why in just a second. So first thing is to go to math, grab this bounds, the one that says min max. We want to know what our boundaries are here, and then grab the remap. Okay. And we're remapping all those values. This is our source domain. And then we'll go ahead and leave the target domain between 0 and 1. And the reason why we're going to do that is because we're going to go to parameters and grab the graph mapper. And this graph mapper likes to work between 0 and 1 unless you set custom values. And I find it slower to do it that way. It's just a preference. So instead we remap between 0 and 1, so we can put all of our remap values in here, and we're going to use this to kind of change up and affect our gradient in just a moment. The next thing is going to be to use these values now against this random set of numbers to basically pick and choose which ones stay and which ones remain. Okay. So let's, I'm going to just expand this a little bit so we can see a little bit more. And I'm going to go to vector. Math, operators, and I think we want to use the smaller than. All right, and the random set of numbers will go into here, and this remap values will go into here, and this is going to give us a true-false pattern that we can then apply to our sets of points. All right, so we'll go to vector. I keep doing that. Sorry, set. sequence, and call pattern, okay? Because that's a pattern of trues and falses. The thing that we're getting rid of, or the thing that we're starting to decrease in number, is the points themselves. And that's going to come out of this remapped component. The original, remember that we took the original ones and we reordered them numerically. All right, so you can't see any change, but there is a change there data-wise, so you want to use those. And then the output of this component over here, the less than, is going to be what we're going to plug in there. All right, and then we're going to have to turn off the preview for this one in order to see what we've done. And you can kind of see it starting to work. We're removing more from the ends and keeping more in the middle. If we play around with this, we can even get more distribution toward the center and less removal toward the center. And here is even going to allow us to remove more from the edge. All right, so as we play with this, you can see that you can kind of, in a way, fine-tune the result. Okay. Now this is where, you know, we can go back and add a bunch more points, and trust your computer. I mean, in my case, I'm going to crank it up to 5,000. If your computer's a little bit older and it's, you know, a little tired, you can use a lesser number here. It doesn't really matter. Okay, that looks pretty good. Maybe I'll play it around with it a little bit more, remove some more like that. Yeah, so we've got a little gradient emerging here that we can use in a different way. So let's look at that in plan view. You know, similar idea being explored, right? I mean, you're still seeing your general viewing angle, but you're seeing it now in a different way. You know, we're starting to look at it more like a cloud that starts to disappear as we move toward the edge. All right, let's keep customizing this and add some geometry to these points, because these aren't quite yet ready for prime time. So a simple way to get started is to just head over to curve, and we'll just draw some circles, right? Primitive circle. And you know, by default, these are going to be a little too big. We can turn these points off, and we'll just change our radius to something much smaller. There you go. So already we have a nice pattern emerging, something that you know, simple enough, but is kind of a nice custom visualization. And again, it's going to depend on what your graphic style is and what you're going for, but it's a good start at least getting you thinking, I think, creatively about how to use some of the data coming out of the Ladybug analysis. But we're going to keep playing around a little bit here. We're going to show some more control over the circle size. We know that this is a numeric parameter, which means we can put a gradient into this as well. They can get larger and smaller as well. So let's play around with that a little bit. So to do this, we can use these numbers, right? Because these, you know, these are setting a gradient up for us, but we'll also have to run another call pattern on the numbers themselves. All right, so let's go to set, sequence, call pattern. Go ahead and plug that in. And the pattern, so now we're removing, so now we've got, so here, if you look, we've got 5,000 values, but here actually we only have how many circles? 1,586 circles, right? So you can't use the same, so that's why we have to use the same calling pattern to remove the same number of things, the same number of points that we did before. So we have to apply that same kind of operation to the data as well. All right, and now we're going to have values that are maybe a little bit too large for circle radii, because, you know, again, if I plug that in there, you're going to start seeing some overlap. I mean, it's kind of cool, but you know, we're going to want to do two things here. One, we're going to probably want to, I mean, unless you're trying to show how far away something is, this might be useful, because now the farthest something away is, maybe you're showing that distance as a radius. But if the data itself, in terms of the number, is what you're after, then this makes more sense. This is further away, it's bigger, and vice versa. But if you're going to talk about how things might be actually seen, then obviously the opposite makes more sense. And in that case, you can just simply reverse the result coming out of that call pattern. You know, and that's going to give us our big circles in the middle, which are closer to our viewing point. Now let's talk about controlling these radii a little bit better. Okay, in terms of their sizes. So we can do another remap on that. So let's go to Math, Remap. We're going to also grab the min-max again. We want to know what that is. remember, we can't use this one because we've affected change here using the graph mapper, so we have to recalculate that. The values themselves, pretty self-explanatory, I think. And then we just got to tell it what our target domain is. So let's construct one. So I'll go to math, construct. And here's where we could put in a couple sliders between 0 and 1. So I'll just throw this in there, and I'm going to turn this down quite a bit. Copy and paste that over. And maybe bring that up to something like that. See how that goes. You can plug that into T, and then this can go direct into, yeah. And this is going to set your maximum, right? So you can eyeball that to make sure that you don't get any overlap between the circles. And there you go. So now we're getting pretty close, and that's our maximum sizes, and our minimum, we can make those a little larger if we like to make sure that they're still visible. But here we've developed what I think is kind of a nice scattering of different size circles based on the distance they are away from our centering viewing point. Okay. And again, this is all coming from the information that came out of, first of all, this, but then we're starting to build on that by adding, more data, more geometry, and more data points to work with. And in the next example, and then the one after that, we'll show how we can use the direct numeric information coming out of the analysis to do some pretty cool stuff. All right, this one is almost there. I wanted to talk about a couple more things before we move on. First thing, I guess, is going to be going back over here, knowing that, remember that you can change your target domain here as well. So I'll just go ahead and copy and paste what we did over here. And maybe make a couple changes, bring that down to something small. You can maybe leave that alone and plug that in. And now this is going to give us a different approach to the removal of points, which is also pretty nice. So we've got even more of a fine grain, control. Remember, this is not affecting the radii. This is going to affect what comes in to this in terms of its removal of points. So, the two things are a little bit redundant. I mean, leaving this between 0 and 1 is just fine, but sometimes it's nice to have a little bit more control that's slider based, and then be able to fine tune it just a little bit with your graph mapper. So it was just a note, in terms of keeping in mind that you can use these sorts of remapping and domain and custom domains in a variety. Apply that to a variety of different things, and in this case, it's to the call pattern, direct, and in this case, same components are being applied to the radii of circles. All right. So I'm just going to disconnect that and leave it where I had it. I thought this was pretty interesting, and then we'll keep going. All right. So let's wrap up with one more thing. Which is going to be now a different kind of option for vision. So in this case, this is just some circles. So it's a kind of it's a field condition of similar items that are different size. What I'm going to do instead is draw lines to kind of give it the same data, a little bit of a different appearance. So the first thing I need is a 2-point vector. Okay, and we got to go way back in time here. And I'm going to just plug a little point parameter into our center point here so I can bring it over to the other side of the screen more easily and let that sit. I'm going to go to vector 2-point. That's going to be our starting point. Okay. And the points that came out of here, these are the centers, are going to be the endpoints of those vectors. We can turn that off. And we're going to use this information to draw lines. So we're going to go to curve. Line SDL is in the primitive tab here, so we can go to line SDL. The start point for all of these is the same point here from center out. The direction, we can actually use this vector. And then the length can also come right out of that component. So you can see here we've got quite a bit of lines being drawn, and it's a bit intense. So for something like this, we might want to then add because we're building on an old file, what we probably want to do is, you can either go back and reduce the number of points over here, you know, and that'll give you less lines. But because we're, you know, I'm going to use this opportunity to show you another component. So one thing we could do now is just kind of randomly reduce the number of lines we have. We don't want to pick and choose which ones we want to remove. Sometimes it's easier to just let the computer decide. So we'll go over to set, sequence, random reduce. The list is the lines themselves. I'll disable that preview. The number of items to remove is a variable that you can set custom. All right, so we have this many things, 1,799. I'm just going to put in 1,000. You know, I want to reduce these a lot to really see the effect of this thing. So we're going to reduce that, and you can see now that we've got a lot less lines, 1,000 less lines, and this might make for a little bit of a better visualization. I mean, you could even remove more if you like. Maybe we'll start with that. All right, and then the other thing I like to use a lot is the dash pattern. So we're going to go to curve, and where is this thing? Division, dash pattern. We can turn off the original preview and then just plug in a slider into the kind of the PT input. And this is pretty nice. So we can zoom in here, and you can see that the smaller this gets, whoops, careful with this. Going down to 0 will cause it to fail. Uh-oh. Oop. There it is. Whew. Almost died there. Yeah, so actually it's kind of nice. You know what I'm going to do? I'll show you a better way. Make sure you use a slider that's between, you know, I'm just going to say 0.1 and 1, so that we never really go down to 0. You know, and that will help. And then you can edit that, I guess, because, well, here's a better way to do it. Sorry. Type in 0.001, or maybe even 005, or even 0.1. Yeah, that might be a little bit better. Yeah, that'll give us a little bit more control. There you go. And what's kind of nice, because all the lines are next to one another, they're starting from the same point, I should say. Because they're starting from the same point, the little dashed lines are going to line up with one another to give you this kind of bullseye effect, which is that's free. You know, that's a kind of a free win from doing something like this. So you get an elegant line, but at the same time you get a kind of pattern that emerges just from the line type itself. You know, which in this case I think makes some sense because it's a radial condition we're talking about. And then, you know, for this I'm just going to change the color. And I think, you know, again, probably starting to get used to this part. So it's just a custom preview and a swatch. Pretty nice. And this can be baked into Rhino as segments. But obviously be careful when you do that, because you're going to get a lot of things, a whole lot of segments. All right. So you're going to want to put it on the right layer, get it to the right size, and probably never touch it again until you start to add line weight to it. But you're going to want to put that out as a single layer, on its own separate layer, I should say, so that you can always turn it on and off when you get it into Illustrator, or if you're going to print from Rhino, you know, happen a little faster. And, you know, if you wanted to, you can experiment with how you could, you know, overlay the two patterns, which might be interesting. If you wanted the circles to be only at the endpoints of those lines, you have to run the same random reduce on the circles themselves. And we can disconnect that one and pop this one in. And that should get you pretty close to that. Looks like it's working. Yeah, I mean, randomness is never really truly random in Grasshopper. I mean, you have these things called the seed, and that could give you a different random result. But these two components with the same seed, because these items are actually ordered in the same way because they come from the same center point, means that you'll be you're going to be reducing things that are relative to one another. Okay, that's it for this one. It gives you some idea for how you can take some of the information coming out of view rows and completely transform it for your own kind of graphic style. Oh, and I guess because it's quick, we can just throw a hatch on the circles. Why not? And that gave us a solid hatch. Maybe we want to make that different color. Yeah, maybe we'll. Where is that coming in? Is it this one? Nope. Hatch name. Is it shader, not scale? Oh, right. It's actually this stuff coming out of there, so we can just simply add that. There we go. Yeah, pretty cool. Maybe we can even speed it up a little if I copy this over. Solid hatches are going to be a little slow because it makes a surface, you know, so you want to be really careful with this. Unless you know for sure you're done. If you go back and make a change in the parameter, it could really bog down your computer because the output here is surfaces. And maybe that's one of the issues with this. But in any case. All right, let's take this down to, yeah, what is that? Hatch 2, sure, whatever. Hatch 1 might be better for this one, and then we can change the scale to something much smaller, and this will speed it up a little. It'll look pretty solid without actually being solid. That's a little small. There we go. No. Oh yeah, there you go. That's pretty cool. Okay, I think you get the idea. Have fun. Make nice things.